All right, today's lesson in math, we are starting chapter 2. And like I've been telling you, where the 0, the 1s is, we've been doing everything to the left of it. We've been going from the 1s to the 10s to the hundreds, thousands, millions, billions, okay? And we did that. Now, that's all covered. Instead of going to the left, we're going to go to the right. In other words, we're going to find where there is a decimal point. So if we had a number of 1,056, right here would be where the decimal point is. We've been covering everything this way. Now, we're going to go this way, okay? And the way that we are going that way is we are going to start by heading over. Now, we had before where you had the place value, where you had the hundreds, the tens, and the ones. Okay, so you had 582. Okay, does everyone understand that? Follow along, Austin? 582. Decimal point would go right here. The next space, and next space are what we're going to talk about. This is going to be the tenths, and they're going to have that THS on it. This is going to be the hundreds. With the THS on it. And then you're going to have the thousands.
Alright, that's the most. Okay. 10. Where's the 2? 10.
With
on the bottom to the right.
A THS. So if you, let's see, Cece, do you swim?
Used to.
You used to? Okay. You swam a race, a long race, and it took you 582 minutes and 8.17 seconds. 582.817 seconds, okay, which would be 582 seconds, 60, just under 10 minutes, okay, a long race, okay. They do these races sometimes to the hundreds. Sometimes they'll do them to the tenths, okay? If you are, used to be, way back a long time ago, they had what was called the 100-yard dash, okay? Now it's the 100-meter dash, okay? And when they had the 100-yard dash, they had people that ran it, and when they got below 10 seconds, okay, it started getting they were really fast. Who is it? Usain Bolt? Usain Bolt. Okay. He would probably run the 100-yard dash in, I want to say, 8.9 seconds. Okay. Which means there would be an 8, a point, and a 9. 8.9 tenths of a second. Tenths with the THS. This is tens over here. That's it. No THS. Okay? This is hundreds. Hundreds. No THS. Okay? Now, let's talk about money. Okay? if I have 57 cents, how would you write that? 0.57. How many hundreds do I have? 7. How many tenths do I have?
5.
5. In other words, I have like 5 dimes, and I would have 7 pennies, okay? Because there are 100 pennies to make $1, okay? This is where, if you can relate it to money, it might make it a little easier. Now, you can't relate thousands to the money. You don't get it, Brian?
No.
Okay.
I did it.
$1.57. Okay? That means I got $1 bill. Okay? I have 5 dimes. It could be 2 quarters, yes. It could be 10 nickels, yes. But I'm going to say I got 5 dimes because the dimes are tenths. Okay? And I also have 7 pennies. There's 100 pennies to make $1. So if I had 7 of them, I had 7 1/100ths of a dollar. Right? Okay? If I had 5 dimes, I need 10 to make $1. No, I have 5 tenths.
Oh, I see kind of now.
Okay? It's 5 tenths.
It's 700. It just goes the opposite way.
Yeah.
I know it, but I get the first part.
Now, what they are doing here is Austin, instead of Sahir, Austin is building a model house. The directions state that the window should be this inches wide. Okay? It's got to be a certain width. In order to describe this to his friend, Sahir will say that the number name of this decimal. What is the number name for 0.750? What is? No, this is going over what we did when we were going over here. So when you said that this is 582, okay, last chapter, we talked about 582, okay? If there was a bigger number, how did you say it? Christian, say it out loud. 182,000. And if I put that in words, ONEHUNDRED EIGHTY dash TWO THOUSAND 182,000, and then THREE SEVENTY SIX 182,376. Okay, we're doing the same thing. If I said this, you would say, what is this? What is it? $1.57. Okay? Because we got the dollar sign. Now, here, 75, and where does it go to? 75 hundredths. So you go to where the last digit is. So even if you wanted because there's a 0 on the end, you could go 750 750 thousandths. Or because there's a 0 on the end, that's not changing anything, okay? You can have 75 hundredths, okay? 75 hundredths. So they're asking you for the number name, the words. If you were to say this number, okay, how would you say it?
750,000?
750 thousandths. So all you would do is write 750 thou S-A-N-E-T-H-S, thousandths. Okay? Thousandths puts it on the right side of the decimal point. If you said 750,000, you're on the left side of the decimal point, because you don't have that THS in there. Then, if you were to write it, 750, and your decimal point is right there. What? Go ahead.
So when you go like the 0 point in number name, whatever, how do you write like a point? Do you literally write the word point, or?
No, you're going to use the word and. So if you had $1 and 57 cents, that and is where your decimal point is. The decimal is always coming right after the ones digit. Okay? Between the ones and the tenths. Okay? So if you have whole numbers, they're on this side. And these are not whole. There's not enough there to make a whole thing. Christian.
How do you write a decimal?
How do you write a decimal?
Or like, it says 945 over 1,000. How do you write that? That's the fraction form.
We're getting there to that. That's the next part where we're going to get to. Now, down here they have, these are in standard form. Okay? 0.003. Where's the 3? In the thousands. So 3 thousandths. That's all that you write for it. Then you have 1.065. 1 and. Harper, that answers your question on how do you write the decimal. 1 and. And then 65 thousandths. Okay? Even though there's a 0 in here, it's still 65 thousandths. Yes, Cece.
Is that why we were never allowed to like write and in the word forms?
Yes. Because last chapter, you couldn't put 182,000 and 365 or 376. Because if you put that word and in there, that stands for a decimal. Okay? There's certain words that you're going to key in on. Last chapter you ran into the word difference. What did difference mean that you had to do? Liam?
Addition has like a sum, which is an answer, and subtraction is difference, which is like.
Yes. If it says sum, you're adding. If it says difference, you're going to be subtracting. The word and, Harper, and that's a great question, stands for the decimal point. Okay? So you would have for here 1 and 65 thousandths. And you notice that they have these THS's on there. Here, there's a 0. Do you have to mark down the 0 in the word form? No. If you did, you'd say 0, Z-E-R-O. And, very good, Harper, we got it now. We're gonna call it the Harper rule.
Oh no, please don't.
We need a rule for you.
How about my name?
No, we want Harper's. She's the one that asked the question. I'm giving her all the credit for it. So this is the Harper rule.
I'll say this.
So if you do this in your paper and you mess up and forget the word "and," I'm going to say, what's the Harper rule?
Oh no. Everyone get it right. I'm probably not gonna get it right.
So here we would have,
I'm gonna get it right.
Yeah.
all right,
Yeah.
here we would have 0
I'm right there.
and, Harper rule, 278. Isn't this 278? Is this 278?
No.
If you were to look, I haven't got to that far yet. If you were to look at this number, would you say that it's 278?
I think, yeah.
Okay? Then if you put thousandths with the THS on, that's going to put it behind the decimal point. So when you're reading that, you would say 278 thousandths. Here, this is behind the decimal point. Don't look at what's in front of it. What's behind it? You see a 65 thousandths. Up here, 3 thousandths. Okay? So when you are looking at these numbers back here, even if you had this one up here, if you look at it, 750 thousandths. Okay? And this is as far as we are going over, is 3 spots from the decimal point. Now, the other part that they say, if each hundred in a whole is split into 10 equal parts, there will be 10 times as many total parts. So if you were to take this is a hundreds thing. Okay? There's 100, there's 10 across, 10 down. 10 times 10 is 100. Okay? So there's 100 squares in there. If you were to take one of these squares and break it into 10 more parts, and that's what they're doing here, that one square to here, 10 more parts. So there's 10 here, 10 there, 10 there, 10 there, 10. You're multiplying it by another 10. So with 100, when you have 100 and you multiply it by 10, we did this last chapter, add a 0, which you can also put it as a 1 up there, exponent. You're going to have 1,000.
You lost me there.
Lost you where?
Just when you explained that.
This is 100. Okay? This whole thing right here, there's 100 of these in there. Are you with me? Okay? Now, what they're doing with this magnifying glass is they're looking at one of them. Just that one red one. And that one red one is broken into 10 more pieces. Okay? There's 10 lines.
But then wouldn't they all
Because it's 10 by 10, so then the red one is one of the 10s inside the line.
What?
Yes.
What? So you could keep
This is just showing you that it's one of the 10 that's in there. But there are 10 of these lines on that. Okay? You want me to help your head feel better? Here, this one, hold up, hold up. This one square is this square here. And it's divided into 10 pieces. This one square is this one right here. Okay? And it's divided into 10.
So it's, so now
There's 10, there's 10 lines, there's 10 pieces in this. Does everyone see that? Okay? This one is in there. If they wanted to make you a 1,000 square grid, they would have to have 100 down and 10 across for it to be 1,000, right? 100 times 10 is 1,000. So they would have to have 100, they'd have to have 10 more of these grids, 9 more, because you got one here. You'd have to have 10 of these grids lined up to make 1,000 grid. This is 100 grid, Luke, right? There's 100 in here. In order to do a representation like this, but with 1,000, okay, I would have to have 10 of these. 10 of these to make 1,000 grid. So then if I had to show this 3,000, I would end up coloring in 3 in one of the 10 grids. And that would represent it.
Wait, so they're saying that like that one little dot has like 10 in it? Is this like a Rubik's Cube or something?
Yeah.
They could just make
Rubik's Cube, a cube, if it's 10 by 10, and I know Rubik's Cubes aren't,
They could be.
they could be, but if they are a 10 by 10 by 10, there's 1,000 of those squares in there, okay?
Or you can just make a piece of the light.
10 times
Yeah.
10 is 100 and 100.
Now-
There's 10 and 100.
Things that you are going to have to do today. Things that you are going to have to do today. And you're sitting there going, oh, Mr. Mink, this is so much. First of all, but it's simple. Once you catch on, you will catch on. Harper, you will catch on, and you're going to say, oh, this is easy. Because right now you're like, oh man, this is hard. But then once you start doing it, oh man, Mr. Mink, this is so easy. And by the time of the end of the chapter, you're going to look back at this one going, oh man, that was so easy. You will. First of all, they are showing you ones that are over 100 fractions and fractions that are over 1,000. Okay? If I told you $62,000, if I put a 0 on the end here, that would make it 620, right? Wouldn't it? If I put a 0 on the front, would it still be 62?
No, it would be it. Wait, yes.
It'd still be 62. So if you have 62, follow along. If you have 62,000 written like that, one easy thing to do is to put a 0 in front, and then you're also going to put a decimal point. Is that still 62,000s? Okay? If I had, what is this? 40 100s, right?
What
Okay?
if you have like 45?
Five what?
What if you had like 45?
45 hundreds or thousands?
45.
If I put a 0 here, would it be 45? 450. I'm gonna write it on top of each other so you can see the difference. If I put a 0 there, it makes it 450. If I put a 0 here, it keeps it at 45. Okay? So what you're gonna do is if you have that, you're gonna put a 0 there, and 45. Now, what happens if you have 3?
You put 2 zeros on the back of it. Or on the front.
On the front. So if you put them on the back, it'd be 300.
I see you. I see it a little bit. I see you.
Okay?
I sort of see you.
What happened to so many zeros? I thought they teach
What number?
Whoa, what the
Okay.
those zeros?
Now, Riley asked a good question. She goes, what happens if you have, I'm gonna give you a different one, 14 and 1, or no, 2 tenths. Okay?
I know what it says. I know what
Okay?
it says.
Now, if you know, wait. Over here, is there a whole number here?
Yes.
Do we have any whole number here?
No.
No, there's no whole number here. Here there is a whole number. And then the fraction of the 10. Okay? Then the fraction of the 10. Okay? So I got 14, then I got the Harper rule. Harper rule. And then the 2 goes in the 10th spot. Because it's 2 tenths. If
I'm not getting it.
look, that's 2 tenths. 14 and 2 100ths is 14 Harper. And what? And what?
0, 2.
I mean,
0, 2.
0, 2. Because if I made this 20, if I put a 0 behind it, it would make it 20 instead of 2, Ryan. But if I put the 0 in front, it keeps it at 2. Cece, try this one.
So you're saying that like the 0 doesn't go behind it because then it would be like a 2 tenths, so the 0
That's going to make the number bigger.
So the 0 kind of keeps in like its place that it's supposed to be in?
Yes, the 0 keeps the number in a place where it's supposed to be. Okay? Because if you have your 2 tenths over here, if you have your 2 tenths here and you put a 0 in, all of a sudden you're moving the 2 over here and the 0 there.
So the 0 holds it in.
If you put the 0 here, that keeps it there. Okay?
So it kind of just holds it in.
Yes. So this one is 2 1,000ths. So we would go back to 14. And what's this?
0, 0, 3.
Harper rule.
Harper rule.
0, 0, 3.
0, 0, 2.
3.
0, 0, 2.
Okay, now what about
This is a 2.
the 2 zeros hold it in its place thousands, it's like kind of times by thousands.
No, there are 3 zeros, but one of the zeros is taken up by the actual number.
Oh! Okay.
I see what you're saying, Luke. And Luke, you're onto it. There's just one little thing that you're missing. This 2, I'm going to put it over that 0. So that 0 is already used. Now, I need the other 2 zeros up. Huh? The 1 just stays alone. Why?
Because
no one likes
the one.
It was like what we did before where you had 100 times 10 to the second. Luke, when we had 100 times 10 to the second, you added 2 zeros on, right? But you didn't add the 1 in too. You don't. Because it's 1 times 1. 1 times 1 is 1. This is the 1 that goes with the whole number. Okay? So the way that you were saying it, Cece, is correct.
Was it the zeros that hold the place because you can't put the 2 in the tens? You have to put it in the thousands place?
Well, here, if I were to move this one over, then it's right over that. I got 1 0 I need to bring up to hold that into the hundreds place. Okay? And this one is over the only 0 that's there. So there's nothing, you're just putting it right after the Harper rule. Yes, Harper.
Can I go to the bathroom?
In just a second, I'll send you.
Can I go to the bathroom?
When I get to it. We're just about done.
I knew it.
Now, your work today. You are writing the decimal. In other words, you're having numbers and you're writing the decimal. If there's a whole number, something before the fraction, that goes on the left side. Liam, pay attention so you know what to do. This is going to not take long. That goes on the left side of the decimal point. Okay? And you're going to, if it asks you to do the word name, what's this? The Harper rule. And. So you're going to have 14 and 2 thousandths because that 2 is in the thousandth spot. Now, first of all, you have to write them as a fraction. There's like, or no, you're writing the fraction as a decimal. Please pay attention. You're writing the fraction as a decimal. Then you are writing the decimal as a word name, as a name of it. In other words, you're using the words. If I said that this was 3 thousandths, I would write out THREE. That's the word name. Then you have write each in standard form. They give you the word name. Now you got to put it in standard form, like this, like this. Okay? Remember, if you see the word and, the Harper rule, that means there's a decimal point there. What's before and? What's before and is a whole number. What's after and is the fraction, is the decimal. Then you have write an equivalent decimal. This is the easiest part. Easiest. Okay? When you are writing an equivalent one is 1.7 the same as 1.70?
No.
Yes. No. No. I kinda get it. No. Wait.
No.
Yes. No.
It is.
Yes.
The reason why.
No.
This is a dollar. If you think of money, go back to money. Okay? This is $1.07 what? Yeah, no, this isn't 7 cents. 7 what? 7 dimes. Right? This is 1.70 cents. $1.70. This could be 70 pennies. Is there a difference between 70 pennies and 7 dimes? Are they the same? Okay? One is smaller increments, but that adds up to the same as the bigger increments that are dimes. So if you have 7 dimes, it's the same thing as 70 pennies. The easiest way to do these is you add a 0 on the end. It doesn't change it. Putting a 0 on the end does not change it. It leaves it the same. So if you've already got a decimal that is if you put a 0 on the end, it doesn't change it. If you put 2 zeros, 3 zeros, 4 zeros, it doesn't change it. You still have 12 and 17 hundredths. But if you have 170 thousandths, it's still the same amount as 17 hundredths. 170 of something is the same as 17 tenths or hundredths. Okay? Christian.
Wait, or does it, if you're trying to write decimal as like a tenth, you put like the 0 after 10? Wait, no.
All of your ones that you are doing are like this. All that you have to do is show an equivalent is you're putting a 0 on the end. You're breaking it, that one thing that you have, into more pieces, but it's still the same amount. It's just in more pieces. It's like if you had a piece of pizza. You had 1/10 of a piece of pizza. Okay? You get a pizza, a large pizza, and they cut it so that there are 10 pieces of pizza. Okay? Food always gets across to people. Food and money. You take one of those slices out. Okay? You cut it into 10 more pieces. Basically, you're taking that 1/10 of a piece, and now if you did all the other 10 pieces into that, you'd have 100 pieces. Right? Now, that 1/10, if you had 0.1, okay, and you cut it into 10 pieces, you now have 10 100ths. But you still have 1/10. It's still the same amount. You just got it into smaller pieces by putting a 0 on the end. It's still the same amount. It still equals it. If you have the 7 dimes and you put a 0 on the end, now you have 70 pennies. Are 70 pennies the same amount as 7 dimes?
Yes.
Is it this? Do you have more money if I gave you 70 pennies and I had 7 dimes? Who's got more money? It's equal. I have 70 cents. He's got 70 cents. He has more pieces of metal or whatever, but it's the same amount. If I go to the store to buy something that's 70 cents, he can go and buy the same thing. Even though he's got 70 pieces, And the cash register person's gonna hate them because they gotta sit and count 70 of them, rather than me, where I walk in and give them 7 dimes. Oh, 1, 2, 3, 4, 5, 6, 7, and they're done.
1, 2, 3, 4.
So it's the same amount. The only thing is it's broken into more pieces, but it's still that same amount. Okay, Luke? Does that make sense?
Yes.
You get that 1/10 of a piece of pizza.
Okay.
Okay? Put it off to the side, and I cut it into 10 more pieces.
Now there are 100.
But that one piece that I just cut into 10 pieces, it's still the same amount, even though it's 10. It would be the same amount as if I took another piece that was the same size and everything and put it off to the side. That one is the same amount as what you have that you cut into 10 pieces. Okay? So by adding a 0 on the end, I know. By adding a 0 on the end, you're not changing the amount at all. It's still the same amount. It's just more pieces. You're dividing it up into more pieces. Okay? And that's what they're asking on 29 through 44. That is going to take you about 3 minutes to do. Because all that you are doing is you're adding a 0 to the end of each one of those. That's it. So number 1 or number 25, 1.9. Huh? If they already have a 0 on there,
Add another 0.
you can add a 0 or you can take a 0. You're not changing anything in the front part.
But what if it's like 8:30 and
You can cut it all the way, take all the zeros off. If you had 300 of something, this goes back to $8 and we're gonna say that this is 30 cents. If I take the 0 off, that's $8 and still 30 cents, but it's $8 and 3 dimes rather than $8 and 30 pennies. Okay? So if there are zeros on the end, you can take them off or you can add on to them. The zeros at the end are not going to change the amount that is actually there. Okay? Then you have 45 through 49. Write the name of the number of thousands.
Where's a number as a number?
If there isn't a number there, what would it be? You ran into this on your test. If there's nothing there, it would be a what, Ryan?
A goose egg.
0. Goose egg.
Yes.
Your test that you had for chapter 1, they underlined a 0. I think it was in the 100,000 spot.
Yeah, I remember that.
Yeah, and they said, what is the place?
It's nothing. Well, the
But what is the
place?
place? 100,000. What's the value?
Nothing.
Nothing. So if if they say this one here, what is in the 1,000th spot?
0.
0. What's the value of it?
Nothing.
Nothing. What about this one?
3.
What's the value of it?
3,000.
3,000ths with the THS. Okay? Guys, this is easier than you think. All that you are doing today is 1 to 52, and a bunch of them you're going to be through in a couple of minutes. And there's no IXL, and there is no more practice today.
Wait. 1, 2.
52. That's it.
Okay.
No workbook. Girls that need to go, walk. Walk if you need to go. Boys, if you need to go, walk.